Okay, so anyway, yes, Le Chatelier principle states that a system at equilibrium will react to a stress in a way that counteracts the stress. So when we're at equilibrium, remember equilibrium means that the reaction an equilibrium reaction goes in both directions. Okay, at equilibrium, the rate of the forward reaction is equal to the rate of the backwards direction. Okay, and then you have a ratio of products over reactants, and we call that the equilibrium expression, right? That's what we talked about last time, the equilibrium expression, right? When we have products over reactants, we get a certain ratio of numbers, and that ratio is held constant at any given temperature or pressure. Okay, so if you recall, these are the equilibrium expressions. These ratios will stay constant. Okay. Also, from the work we did the other day with this one, if you recall, I forgot to pull these up, so it might take a minute here. But basically, the ratio of products over reactants is constant as long as we are at equilibrium. Okay. So if you remember this, we go down to the bottom here. So you remember that when we had a reaction at equilibrium, eventually the change in the forward and the change in backwards are equal, and then we have a ratio of products over reactants. That is known as our equilibrium constant. Okay. And it's a constant ratio. Now, what Le Chatelier is, if we put something into the reaction that causes a stress on the equilibrium, that equilibrium will shift to reestablish equilibrium. Basically, it's going to, like I said, it's going to reestablish equilibrium. So the first type of change that can occur is change in the concentration of the reagent. So if we have a reaction like this one on the right here, CH4 plus H2O is in equilibrium with carbon monoxide and H2 gas. Its delta H is positive 210, so that means it's endothermic. We'll get to this in a second, but let's deal with this first. So let's say, for example, we artificially add some CH4 to the mixture. So this reaction is at equilibrium. Okay, this reaction is at equilibrium, and then we add some CH4 to this reaction. Okay, now what Le Chatelier says is this reaction will shift so that the stress is so we can get rid of that stress and we can reestablish equilibrium. Okay, if you think about it here, the equilibrium expression would be CO. Oops. Let me write it down. So the equilibrium expression here would be products over reactants. So concentration of CO times concentration of H2 to the third over the concentration of CH4 times the concentration of H2O. Okay, now this is going to have a specific ratio of numbers. I'm just going to make it up. Let's just say it's 1:1. It doesn't matter what it is. Okay, 1:1. Doesn't matter what it is. Let's just say that's the equilibrium ratio, 1:1. Whatever, doesn't matter. If we add CO here artificially, if we add some of this number goes up. Okay, that means this is going to go up. This number is going to go up. So what we need to do is we actually need to bring that number back down. We need to bring that number back down. We also need to bring this number up, okay, to reestablish that 1:1 ratio. So what's going to happen is this reaction is going to shift away from this stress. So if we add CH4 here, the reaction is going to shift to the right. It's going to shift right. Because now we have too much CH4. So I always think of it, if we increase something, it's going to overflow to the other side. The whole reaction is going to shift to the right. It's going to shift to the right. And what's going to happen is that the concentrations then of CH4 will go down, H2O will go down, and then CO will go up, and H2 will go up. If we add artificially CH4, okay, it's going to shift to the right. It's going to shift away from that stress. Okay, so we're changing the concentration of any reagent, adding it, it's going to shift away from that. It's going to cause the reaction to shift to the right, and then we're going to get less CH4, less H2O, more CO, and more H2. Okay, we can also have it if, let's say we add more H2O. If we add more H2O, again, it's going to shift to the right. Because now we have too much H2O. So it's going to shift away from this reactant. It's going to go this way to the right. Therefore, CO is going to go up, H2 is going to go up, and then H2O is going to go down, and CH4 is going to go down. Okay. So the top arrows are the artificial changes, what we're putting in like H2O, and then how does the equilibrium shift is on the bottom here. Okay, same thing goes if we do products. So if we add CO, it's going to shift away from that. It's going to go to the left. So it's going to shift left. Okay, it's going to shift left. Therefore, CO is going to go down, H2 is going to go down, H2O is going to go up, and CH4 is going to go up. Okay, if we added H2, it would be the same thing. If we added H2, these two would go down, these two would go up. Okay, so anytime you add something more, it's going to shift away from that direction. Okay, it overflows. I always say it overflows. On the opposite end, if we remove it, so if we remove CH4, if CH4 we remove it, it goes down. That means we're going to need more of it. So the equilibrium will shift towards the hole that we've created. Okay, so I'm creating a hole here. If I remove it, I'm creating a hole. Okay, remove it, so it's going to shift this way. So it's going to shift left. And we're going to get more CH4, more H2O, less CO, less H2. Okay. Same thing if we remove a product. If we remove CO, if that goes down, we're going to create a hole here. We need to fill that hole, so the reaction is going to shift to the right. Okay, and then these two are going to go down, and these two are going to go up. Okay, so it fills a hole. It fills a hole. Okay, so that's concentration. Changes in concentration. That's the first one. The second one, if we have pressure changes, so pressure and volume changes. Now, we don't worry about solids and liquids. We don't look at solids and liquids if there's pressure changes. We don't worry about them. Okay. However, if the pressure increases, if pressure goes up, it's going to shift to the side with the least moles of gas. Okay, so here we have 2 moles of gas. And here we have 4 moles of gas. Okay. So on the left side we have 2 moles, on the right side we have 4 moles. I just added up the coefficients of all the gas molecules. So this is 1 and 1 makes 2. This is 1 plus 3 makes 4. Okay. So again, if pressure goes up, it's going to shift towards the side with the least moles of gas because we're making it smaller, right? We're making the system smaller, okay? Making the system smaller, and it has to shift towards the side with least moles of gas. So it's gonna, if pressure goes up, we're gonna shift to the left here. If it shifts left, we're gonna get more CH4, more H2O, less CO, and less H2. Okay, now pressure actually, when we change pressure, this will actually alter the equilibrium constant. Okay, so if we change pressure, this is going to change the equilibrium constant because now we're increasing the amount of reactants. In this case, we're increasing the amount of reactants. So the equilibrium constant would get smaller. Okay. We have to be careful because it really depends on reaction to reaction. Pressure can make the equilibrium constant larger, or it can make it smaller depending on the reaction and what pressure is doing. Okay, so again, pressure increases, moves to the side with the least moles of gas, so it's going to shift to the left. It's going to go up, up, down, down. All right, now let's say pressure goes down. If pressure goes down, we're going to shift to the side with the most moles of gas. The opposite, right? So the most moles of gas, so it's going to shift to the right. Okay, so we're going to get more products and less reactants. Okay. So two things here. If the number of moles of gas are the same on both sides, pressure won't change the equilibrium. It won't change it at all. So if you see that it has the same moles of gas, there'll be no change. Okay. Also, the pressure change usually has to be due to a change in volume. So if we decrease the volume, the pressure goes up. If we increase the volume, the pressure goes down. And that's really what's most important. If you're adding a gas that's not part of the reaction, it might change the overall pressure, but that doesn't really change anything. But actually, I'm not even going to concern you guys with that. We're just going to keep it really simple for this. Okay, so that's it. We'll stop for pressure. Okay. The next one is temperature. So the temperature is a little bit tricky. Okay, I treat temperature like as if. So in order to know how temperature changes the reaction, you have to know if the reaction is endothermic or exothermic. Okay, remember endothermic, you're going to have a positive, so this is endothermic. And that means that heat is entering the system. So what I do for temperature changes, I look at the enthalpy change, and I think, okay, well, is heat going in or coming out? If it's endothermic, it's going in. So I count it like a reactant. So this one I would say like plus heat. So I would say heat is like a reactant. If this was negative or exothermic, I would count it as a product. Okay? But here, it's going into the system. It's positive. It's endothermic. So I count it as a reactant. Okay? If I count it as a reactant, I treat it just like I would for concentration. So if we increase temperature, that means we're increasing the heat. Okay, and that means it's going to shift away from it. It's going to shift away. So these are going to go down. These are going to go up, right? And it's shifting right. If temperature goes down, so let's say temperature goes down, that's like we're removing heat. So this goes down. We're creating a hole. So we need to fill that hole so that it's going to shift left. Okay. And we're going to get more of this, less of this, less of this. Okay, because we just created a hole there. Okay, so I think of temperature again in terms of endothermic, exothermic, and as if it's like concentration, as if it's just another reactant or product. Okay, if it's endothermic, it's in the reactant side. If it's exothermic, it's in the product side. Okay, and then the last one is catalysis. This one's really easy. Adding a catalyst will have no effect on the equilibrium. So anytime you see add a catalyst, nothing's going to happen. Na. Okay. So again, we have three things that really change or shift the equilibrium if we change the concentration. And technically, changing concentration doesn't change the equilibrium expression at all. It doesn't change the equilibrium, the equilibrium constant. It doesn't change the constant at all. The constant will stay the same, and that's why we get the shift, is so to keep the constant the same. If we change pressure, though, that does change the equilibrium constant, and that's why it shifts. Same thing for temperature. If temperature changes, we change the equilibrium constant, and that's why it shifts as well. Okay. All right. So your job now is to give this worksheet a try here. So you're just filling in the chart here. You can, as you fill it in, you can just like copy and paste the different arrows, so you don't have to figure out how to make them. You just copy and paste them into the other little things here. Okay. So, for example, here in this reaction, okay, we have N2 plus 3H2 is in equilibrium with NH3 and heat. Okay. Adding H2, if we add H2, that means the equilibrium is going to shift to the right. Okay. So it shifts to the right. The N2 is going to go down. H2 is going to go down as well. NH3 is going to go up. Okay. Now, again, adding those things does not change the KEQ, and that's why it has this little dash here, because there's no change in the KEQ. Okay. So all of these with adding, or removing, the KEQ should not change. Okay. The KEQ is going to change with temperature and pressure. Okay. And it's not going to change with the catalyst. Okay. So give those a shot. Make sure you read through it again if you need to. You have just two problems. I mean, two problems, but a bunch of things to do for them. Okay. And then the answers are given to you at the bottom. So do try it on your own first, and then check your answers at the end. Okay.